Hello everyone, I hope you are doing well. In this video, we are going to solve problem number 20 in the Leetcode series. So let's see what's the problem wants us to solve. First, the problem gives us a string and the string containing different type of parentheses. And the problem wants us to validate the string with some criteria. First, problem wants us to check if this open brackets must be closed by the same type of brackets. For example, if the brackets open with this type and close with this type, this is not the valid string. Open brackets must be closed in the correct order. For example, think that we have something like this, then we have this, then we couldn't close it like this. This is not the valid one. So this is not the valid. So we couldn't open the parentheses and then open the bracket like this, but before closing the bracket, close the parentheses. So this is not the valid string. Then the problem mentioned every closed bracket has the corresponding open bracket of the same type. So we couldn't have something like this, then have a closed bracket like this because we didn't have an open bracket like this before that. We didn't have open here. So this is not the, we can assume that this one is not the valid string. So let's see how we want to solve this problem. To solve this problem, and this is the easy problem, this problem just has a one trick. We need to use the data structure that we name it a stack. Before solving this problem, let's discuss about the stack. What's the stack? A stack is the data structure that we always use to put the items in that data structure. And we always have access to the last item that we put in the data structure. For example, think that I have a data structure. I put number 1 in it, then I put number 2 in it, and I always have a pointer that point to the last item that I put in the data structure. Then I put number 3 in it, so the pointer moved and point to the last item. And always that I want to fetch something, I always has access to the last item. So everything that I put in the data structure that I name it stack, it will be handled like this. Something that I put, the last item that I put in, first item that goes out. So this is the LIFO structure. Last in, first out. Last in, first out. So the last item that I put in the data structure, we always can access it and pop it out. So for implementing this type of data structure that we name it a stack always has two popular methods, push and pop. Push always put an item at the end of the data structure, and pop always fetch the last item that we have in the data structure. So this is the structure that we are going to use. And by using this data structure, you will see that solving this problem is really simple. Think that we have a string like this. We will add these items one by one in the stack. And when we get to the close parentheses or brackets, we will just pop something from the stack. So think that I have a stack and I have this string. And I have a stack here. This is the stack, and initially it's empty. So I'm going through the characters of the string that I have here one by one and put it in the stack. So I'm going to first visit this item. I put it in the stack. Then I'm visiting this item. I put it in the stack. Then I'm visiting this item. I put it in the stack. Then I'm visiting this item. Oh, this is the close one. I need to check the stack. Do I have the similar type of the open parentheses here? Yes. This, I'm visiting this one. The last item in the stack is the similar type of the open parentheses. So I can pop this one. Then I move one step ahead. I visit this item. Oh, this is the close type. Do I have the similar type of the open at the top of the stack? Yes, I have the similar type of the close brackets at the top of the stack. So I can remove this one too and move the pointer one step ahead. Do I have the similar type of the close parentheses at top of the stack? Yes. So I can remove this one and I will reach to the end of the input array and I find that, oh, this is the valid string. So let's implement something that we discuss here in a code. If you implement this one in the Leetcode with the Java, you will see the method signature like this. The method returns the boolean to show this is the valid string or not. And this method receives s as an input. So first thing is first. There is just one trick here. If you see the number of the items that we have here is even. So if the number is not even, we can immediately find out this is not the valid string. So if the number of the length of a string, for example, be 3, it's not valid. It always needs to be even. 1, 2, 3, 4, 5, 6. So it's even, so it's valid. How can I check it's even? So I can check if the length of the string, reminder of the length of the string by 2, not equal to 0. So I can assume this is not the valid string and I can immediately return false. In the other cases, I need to create a stack as we discussed. And when iterating through this string, when we point to the one of the open brackets or parentheses, we need to add it to the stack. The stack contains the characters, and I name it stack. And then as I show you, I need to iterate through all the items that I have in the string, all the letters one by one, and add them in the stack as long as it be the type of the open brackets or open parentheses. So for each character CHR that I have in the array, I need to look through it. Then I need to check, is the character that right now I'm pointing to, for example, if the string that I am processing be like this, through this array first, I'm checking the first character, then I'm checking the second character, and I need to make sure if it's the character with the type of the open, one of these three, I need to add it to the stack. So I need to check if character equal open parentheses or character equal open bracket or character equal the last one. Okay. Then I need to add it to the stack. So if the type of the character is one of them that we use to open, I just maybe it's just to be a little more readable, I just draw it with the different letter. It's one of these three types. In the other case, if the character is one of the closed one, so in the other case, as I show you, I need to pop the character from the stack, the last item. As I show you from this, if this one be the stack, I put open parentheses, open bracelet, then open up this one. So when I get to this character, I always need to pop the last item that I have in the stack and check, is this the same type or not? So I need to pop the last element from the stack to be able to check, is this the same open parentheses as the element that I have that the pointer point to it in the string. Then I'm creating this, I put this switch here and I'm going to check the character. I said, is it the close parentheses? If yes, if last element that we pop from the stack be the same type, if not, I can immediately return false because it's not a valid string. In the other case, I can check the other characters. So, sorry. So what I did here, I checked the character that I my pointer pointed to it in the string, or the character that I'm looping through it, and I see, is the character that I pop from the stack is the similar type of the character that I am on it. Sorry, this is the close, this is the open. That I'm verifying it with the character that I have here. So I need to check the other cases too. I need to do the same things for the others. If you see, this is the same structure, but for the other character. For example, for the bracelet that I have here, if I'm checking the close bracelet, the last element that I have in the stack, is it the open bracelet? And for the last character, I need to do the same check here. Okay. So by this switch case and ifs that I have here, I'm I'm checking that the bracket must be closed in the correct order and the open bracket must be closed by the same type of brackets. This is this section. Open bracket must be closed by the same closed brackets. So I did this check completely here. So, and do I need, can I return true after I did this check and look through all the characters here? Can I, here, can I return true and said, okay, this is the valid string? Think for a second. No, I couldn't do that. Why? Think that I have the string like this. At the time that I'm start checking this string, I put this in the stack. Then I put this one in a stack. I put this in a stack, and I put this in a stack. So if my stack be like this, open parenthesis, open bracelet, then this one. Then I get to the point that I'm emptying the stack. I remove. I sorry. This is a first close one, so I remove this one. Then this one my pointer move here. Then I remove this one. Then my pointer move here. Then I remove this one. But my stack is not empty. So this is not the valid string because I have one item in the stack. So here before I return true, I always need to check and make sure my stack is empty. So I need to check here before returning true if stack dot size equals 0. So at the end, the stack should be get empty. Oh, if the stack is not empty, we should return false. So this is the solution for this problem. And as you see, this is the really easy solution. But the trick to solve this problem was using the stack. And by using the stack, we can easily get the last element from the stack, check the type of the element, be similar type, but for the open cases. If it's it, continue. In the other case, we can return the false. If you like this problem and the way that I solve it, I really appreciate if you subscribe to my channel and follow me on the future videos. If you are looking for the implementation code, you can always find it in the GitHub repository that I mentioned in the video description. And thank you and see you in the next video.